In this class, I'm teaching to you numericals based on energy of simple harmonic oscillator. Energy of simple harmonic oscillator. Okay, so a particle of mass 10 gram. So in the problem given that a particle of mass m is equal to 10 gram, m equal to 10 gram. Executes a linear simple harmonic motion of amplitude 5 centimeter. Amplitude A is equal to 5 centimeter. Amplitude A is equal to 5 centimeter with a period of 2 seconds. Period means here time period, 2 seconds. Find the potential energy and kinetic energy 1/6 seconds after it has passed through the mean position. So for example, this is the mean position. From the mean position, it is moving like this towards the extreme position. This is plus A and this is minus A. So either this side or this side, wherever it goes, from the mean position it is starting. After 1/6 seconds, from this is O and this I'm taking it as P. From O to P, if the particle reached the time factor in the problem given that 1/6 seconds. 1/6 seconds. In 1/6 seconds, after 1/6 seconds, what is the kinetic energy and potential energy of the particle we need to calculate. For that purpose, once the particle is moving from mean position, then immediately we used to take it as displacement y is equal to a sine omega t. Remember this carefully. Once the particle started from the mean position or from the mean position, like that keywords are given in the problem, then immediately we need to consider y is equal to a sine omega t. This is the displacement of the particle. The rate of change in displacement is called velocity. If you differentiate this, then you will get the velocity. Velocity is nothing but what? If you differentiate this, sine became as cos. Differentiation of sine is equal to cos. So with that, v is equal to, here you will get it as a omega cos omega t. Earlier in my classes I said to you, v is equal to a omega cos omega t. Then with this kinetic energy Ke is equal to, what is the general formula? Half mv square. Then you will get as half m v square a square omega square cos square omega t. We need to consider like this. V, already you know that a omega cos omega t with that kinetic energy is equal to, this is the formula. In the problem given that after 1/6 seconds, what is the kinetic and potential energy of the particle? So T is mentioned. That's why I considered this formula. When T is mentioned, then we need to take this formula. In the problem, mass we know, amplitude also we know, time period also we know, and time factor after which need to get the energies also we can know with this formula. Now kinetic energy is equal to half, substitute that 10 gram, convert into SI unit, and that is 10 into 10 power minus 3. 1 gram is equal to 10 power minus 3 kg. 1 gram equal to 10 power minus 3 kg. So 10 into 10 power minus 3 kg. Amplitude is in centimeter. Convert into meters. 5 into 10 power minus 2 whole square. Omega is nothing but 2 pi by capital T. Omega is nothing but, what is the value? 2 pi by capital T. So in the problem given that T is equal to 2 seconds, 2 omega square, so whole square, cos square, omega t again. Omega is nothing but what? 2 pi by capital T, nothing but 2 into T is nothing but, what is the value? 1/6. 2 pi by capital T is omega. 2 pi by capital T is omega. This omega replaced with the 2 pi by capital T. 2 pi by capital T, that is equal to 2 pi by 2. 2 is get cancelled, then pi radian per second. Pi radian per second. Okay. Now, if you calculate that, 2 get cancelled, pi by 6 remains. And then if you take 2 get cancelled here, pi remains. Then K is equal to, kinetic energy is equal to half 10 into 10 power minus 3, 10 power minus 2, pi square 25, 10 power minus 2 whole square, 10 power minus 4, and then pi square is approximately equal to 10 cos square. Here numerator pi we have, in the denominator 6 we have, pi by 6. After taking the calculation of all these things, then you will get cos pi by 6, cos 30. Cos 30 is nothing but root 3 by 2. Cos 30 is equal to root 3 by 2. Root 3 by 2 whole square. Then after taking all these things, then you will get the value of this one is 9.255 into 10 power minus 5 joules. This is the kinetic energy of that particle after 1 by 6 seconds. Then here we need to calculate the potential energy. This is for kinetic energy. Next, potential energy. Potential energy is equal to, what is the general formula? Half m omega square y square. This is the general formula. Already I said to you, when the particle moved from the mean position, what is the displacement? Y is equal to a sin omega t. So half m omega is nothing but, already you know that this is the value, pi square. Y is nothing but a sin omega t. Here anyway square is there, a square sin square omega t. Then after substituting the values, half m 10 gram. 10 gram means 10 into 10 power minus 3, that is 10 power minus 2. Pi square 10, a square 5 into 10 power minus 2 whole square, sin square, omega means pi, t means 1 by 6, sin pi by 6. Then after taking this calculation, here sin pi by 6, pi means 180, 180 by 6, 30, sin 30 is 1 by 2, sin 30 is 1 by 2, 1 by 2 whole square. So substitute all these values in this, then potential energy is equal to, you will get the value as 3.085, 3.085 into 10 power minus 5 joules. Like this, we can calculate kinetic energy as well as potential energy of the simple harmonic oscillator after 1 by 6 seconds from the mean position. A particle is executing S.H.M with an amplitude of 0.2 meter. With an amplitude of 0.2 meter. A is equal to 0.2 meter. At what distance from the mean position the potential energy of the particle? At what distance from the mean position potential energy of the particle? So potential energy PE is equal to its kinetic energy. PE is equal to KE, kinetic energy. What distance from the mean position? So from the mean position, at what distance PE is equal to KE? So it means here we need to calculate X value. So very simple, as you know well, potential energy half m omega square y square, kinetic energy half m omega square into a square minus y square. This is the kinetic energy formula, and this is the potential energy formula at y distance. At y distance, both the energies are equal. That so we need to calculate that y only here. Half get cancelled. M also cancelled. Omega square also cancelled. Y square is equal to, what's the value? A square minus y square. Then minus y square, take this side, plus y square. Then 2y square is equal to a square. Then here y square is equal to a square by 2. Then y is equal to, what's the value? A by root 2. This is the general formula. So straight away remember, even in the exam also like this, at what distance the potential energy is equal to kinetic energy from the mean position. If they ask in the question like this, then immediately you need to remember the formula as y is equal to a by root 2. At that time you can do that numerical not more than 20 seconds. Okay, you will get the you can save more time in the exam. So now y is equal to a is equal to, in the problem given that 0.2 by root 2, 0.2 by root 2, and then that is nothing but you will get it as this 0.1 into 2 by root 2. 0.1 into 2, 0.2. So 0.1 into 2 by root 2. 2 I am writing it as root 2 into root 2. Numerator 1 root 2, denominator root 2 get be cancelled. In the numerator, one more root 2 can be present. So 0.1 into root 2. Root 2 means 1.414 into 0.1. Then that value became as 114 point. Sorry. That value is 0.14. 0.1414 meters. 0.1414 meters. Like this, we can do this problem. At this distance, the kinetic energy is equal to potential. A particle of mass 0.1 kg, mass is equal to m is equal to 0.1 kg, executes S.H.M under a force F is equal to minus 10x Newton. Minus 10x Newton. This is the force value given in the problem. Speed of particle at mean position is 6 meter per second. Speed of particle at mean position is 6 meter per second. At mean position is nothing but that is the maximum velocity. Vmax given in the problem. What's the value? 6 meter per second. Find its amplitude of oscillation. So we need to calculate A value. Amplitude we need to calculate. Okay, so as you know well, we need to consider the law of conservation of energy. According to law of conservation of energy, at any point, at every point, the total energy remains constant. So here, one particle is in simple harmonic motion. One particle is in simple harmonic motion. So that on that particle, some force can be considered. That is F is equal to minus 10 kx. This is in the form of F is equal to minus 10x. This is in the form of minus kx. F is equal to minus kx. Here F is the restoring force. So in the place of k, what we have as 10. In the place of k, what we have? 10. This unit is Newton per meter. This is the force constant. K is the force constant. So once we know the force constant, then the energy in the form of the force constant, here I am taking it as half k x square. Here x is equal to distance. That itself is nothing but amplitude. Half k x is equal to a square is equal to, at the same point, the total energy, that is half k a square, is equal to, we consider the a, x is equal to a means what is the value, what is the concept here, and that must be equal to half mv square. It means at the mean position the velocity is maximum, so the kinetic energy is also maximum, half mv square. If it goes from mean position to extreme position is nothing but x is equal to a. The total kinetic energy is converted into potential energy. This half k a square is the potential energy at the extreme position. Remember this. Half k a square is the potential energy at extreme position. Is equal to half mv square is the kinetic energy at mean position. According to the law of conservation of energy, the kinetic energy at the total energy or the kinetic energy at the mean position is equal to total energy or potential energy at the extreme position. Okay, so try to remember this carefully. With this, half get cancelled, and then I required here a value. So a square is equal to remaining k. You take this side, mv square by k. Then a is equal to square root. This side you will get. If you take the square root, we come out from the square root, root over m by k. This is the formula for the amplitude. A is equal to v root m by k. Now with that, a is equal to v. What is the v value here? 6 root over m 0.1 k. That value we know that here 10, and that is equal to 6 root over 0.1, 1 by 10. Already one more 10 is in the denominator. 10 into 10, 100. So this 100 come out from the square root, then 10 that will get. So a is equal to 6 by 10. Thereby here you will get it as 0.6 meters. So at 0.6 meters, that maximum end, nothing but extreme position you will get for that particular oscillatory motion. Amplitude of that particle is A is equal to 0.6 meters. Amplitude of the particle is 0.6 meters. Hi students, this is the problem in oscillations related to the energy of the simple harmonic oscillator. Okay, now the potential energy of a harmonic oscillator of mass 2 kg, m is equal to 2 kg, m equal to 2 kg, its mean position is 5 joules. It means potential energy at mean position is equal to 5 joules given in the problem. Potential energy at mean position is equal to 5 joules. If its total energy is 9 joules, total energy is equal to 9 joules, and its amplitude is 0.01 meter. Its amplitude is 0.01 meter. 0.01 meter. Its amplitude is 0.01 meter. Find its time period. We need to calculate the t. We need to calculate the t. Okay, now m is equal to 2 kg. Potential energy at mean position is 5 joules. Total energy in the problem given that 9 joules. Amplitude is 0.01 meter, and we need to calculate the time period. T is equal to question mark. So as you know well, at the mean position the potential energy is maximum. So at mean position, the potential energy is minimum, kinetic energy is maximum. Okay, so potential energy at extreme position is equal to kinetic energy at mean position. Potential energy at extreme position, what's the value? Half m omega square a square. Kinetic energy at mean position. What is the kinetic energy at mean position? Here I am taking the concept it as kinetic energy at mean position is equal to, from the total energy I am subtracting the potential energy. Thereby here you will get 9 minus 5, 4 joules. So that value is 4. Kinetic energy at mean position is 4. Okay, now here half m is equal to 2 kg, omega square a is nothing but 0.01. 0.01 means 10 power minus 2 whole square is equal to 4. Then 2 get cancelled. Omega square into 10 power minus 4 is equal to 4. Omega square is equal to 4 by 10 power minus 4. If you take the omega, that side you will get the square root. 4 became as 2 minus 4. 10 power minus 4 became as 10 power minus 2. 10 power minus 2. Okay, now omega is equal to 2 pi by capital T. This is the general formula. Then 2 by 10 power minus 2. 2 get cancelled, and then T is equal to, by taking the cross multiplication, T is equal to pi into 10 power minus 2 seconds. This is the time period of that simple harmonic oscillator.